Hello everyone, this is Vijay. Today I am going to start with the topic logarithms. See, logarithms is totally depends on power and exponents, that is also known as a indices chapter. That's why we are learn about the logarithms. Since in mathematics there are so many difficult problems are here. To make easy calculations, so we apply the logarithms concepts. Okay, but how to apply the logarithm concepts? Let me explain one by one. Even what is the major and what is the basic concepts of the logarithms? That means the introductions part I have already written over here. To make the long and complicated calculations easy. Long and complicated calculations make it easy. That's why we are using logarithms. And the next one, logarithms and exponents are inverse of each other. That means log is totally depends on exponents, even exponents is totally depends on logarithms. That means both are inverse to each other. Let me explain. And now see how this, that is number 2 points, are explained here about the logarithm. That means the definitions of the logarithm. See, this is the exponent form. That means a to the power b equal to c. That means a to the power b equal to c. This is in the form of exponent. Now we have to convert this exponent form into the logarithm forms. Okay, see, log a to the power c equal to b. Log a to the power c equal to b. That means when we are converting from exponent to logarithm, that time b and c are interchanged, become interchanged. That means if you are changed from exponent to logarithms, this b and c will be interchanged. That's why here log a to the power c equal to b. This is called a logarithm form. And this logarithm forms having three constant a, b and c. Here also a, b and c. That means a, b, c belongs to real number, but not it is imaginary. Even log a in place of a, that means this is the base part. Therefore, a could not equal to 1. Why? This will be learned in the class 11 also. That's why you don't know, don't try to know why a is not equal to 1. Okay, since log a, that means log 1 is not defined here. That's why a is not equal to 1. And even this part is read as, log of c, at the base of a, is b. In this way we read these expressions in the form of logarithms. Now how to convert from exponent to logarithms? That means conversion from log to exponents and vice versa. Even you can convert from exponent to log or log to exponent. Is it clear? See, this side is exponent form and this side is a logarithm form based on these two. See, 2 to the power 3 is equal to 8. Even we know 2 to the power 3 is equal to 2 into 2 into 2. 3 times will be equal to 8. And if you will change this exponent into the logarithm form, that times 2 and 8 will be what? Interchanged by these definitions. Therefore, log 2 to the power 8 equal to 3. That means log 8 with base 2 will be equal to 3. Similarly, a to the power 0 equal to 1. Even we know that if there is any base but power is 0, then the value will be 1. That means log a to the power 1 is equal to what? 0. That means log 1 is always equal to what? 0. That therefore you must remember 5 to the power 0. This is the example based on here. 5 to the power 0 equal to 1. So log 5 to the power 1 is equal to what? 0. Even log 5 to the power 1, log 10 to the power 1, log 8 to the power 1 is always equal to 0. That means if base is anything and value of log always is equal to what? 0. Even you see the third one, 10 to the power 1 is equal to 10. That means log 10 base to the power 10 is equal to 1. You also remember this thing, log 10 with log base 10 of log 10 is equal to what? 1. Therefore, you must remember this formula, log a to the power a is equal to 1. That means base and exponents will be same, then the value is equal to 1 if it is in the form of logarithms. So this is the examples from exponent to logarithm or logarithm to exponents. Note, even this is written in the form of sentence or statement. Then how we can write? Log of 8 to the base of 64, log base 64 of 8, log base 64 of log 8 is equal to 1 by 2, is equal to 1 by 2. That means even we can change this log in the form of exponent. That means just you change this 8 and 1 by 2, interchange 8 and 1 by 2. Then this will be 64 to the power 1 by 2 is equal to what? 8. Even we know that 64 of square root is equal to what? 8 only. Is it clear? Now, based on the basic concept or introductions about the logarithms, we have first exercise which is 8a. In this exercise there are many questions and from 1 to 5 all are very easy based on these two. So you attempt by yourself. If there is any problem, I am always with you, but let me solve the question number 6. Okay. Now find x if number 5 and 6. There are 6 questions in the question number 6. I am solving here question number 5 and 6 of question number 6. See, first one, log 4 to the power 32 is equal to x minus 4, and 6th one, log 7 to the power 2x square minus 1 is equal to 0. See the solutions about the question number 5. See here, log 4 to the power log base 4 to the power 32 is equal to what? X minus 4. Is it clear? Then we know that if always you convert log into the exponent, that means you convert this log into the form of exponent. Then how we will change this one? That means you change from interchange from 32 to x minus 4 and x minus 4 to the 32. That means just interchange these two and this will be converted in the form of exponent. So this will be what? 4 to the power x minus 4. 4 to the power x minus 4 is equal to what? 32. And you change both sides with the same base, then power will be equate. So you write 4, you can write 2 to the power 2 and x minus 4 is here, and 32 you can write 2 to the power 5. Since base are same, then power will be equate or equal. So you can write 2 times x minus 4 is equal to 5 and just solve it, and after solving you will find x is equal to 13 by 2. Even you can write in the mixed fraction 6 over 1 by 2. Is it clear? And now see the 6th one. Log 7 to the power log base 7 to the power 2x square minus 1 is equal to 2. In the same way you interchange this. Interchange 2x square minus 1 is equal to 2 and convert this into the form of exponent. This is exponent form. And just simplify this one. That means 7 to the power 2 is equal to 2x square minus 1. 7 square will be equal to what? 49. And just transform from LHS to RHS and RHS to LHS. And this will be 2x square is equal to what? 50. So x square will be 25 after dividing by 2. So x is equal to what? Root of 25. So x is equal to what? Plus minus 5. So x only we consider x is equal to 5 only, but not x is equal to minus 5. Why? See here, you substitute x is equal to minus 5 here. So minus 5 minus 4 is equal to what? Is equal to what? 1. So after you will change, this will be what? Interchange. Yes or no? Therefore minus 5 is not a satisfy for these equations. That's why 5 only accepted here. Minus 5 is not. Please make a note. Please make a note. Thank you. And after this, let me solve some questions. Just note down this one. Now, let me solve some problem from the exercise 8a. After 6, now I am solving the question number 9, 10, 11 and 12. Okay. See the question number 10. Now see the question number 10, 11 and 12. 10, 11 and 12. See, this is the question number 10. It is given if log base 2 to the power x equal to a and log base 3 to the power y equal to a. Then write 72 to the power a in terms of x and y. So first you find the value of x and y. See, we have log base 2 to the power x. So 2 to the power a will be equal to x. Similarly, log 3 to the power y equal to a. That means 3 to the power a is equal to y. How? Just interchange x and a, interchange y and a. Okay. Suppose this is equation number 1, and now we have to find 70 to the power a in terms of x and y. So 70 to the power a, that means just you do the prime factor of 72. So after finding the factor of 72, this will be 2 into 2 into 2 3 times and 3 into 3 2 times. So you may write 2 to the power 3 to the power a and 3 to the power 2 to the power a. So even you can write 2 to the power a to the power 3, 3 to the power a to the power 2. So replace 2 to the power a is x and 3 to the power a is y. So this expression has come from the equation number 1 and this is your answer. Now see the question number 11. Solve for x. Log x minus 1 plus log x plus 1 is equal to log 2 to the power 1. Given. Is it clear? Same thing. So actually this equations is not in this exercise. For these questions we need to apply this formula. This formula you will learn after this exercise. That is called laws of logarithm. But for these questions you learn this formula: log base a into m, log base a of m into n. Break it in the form of algebraic sum. So log a to the power m plus log a to the power n. Apply this. This equations is in this form. So this will be break m into n form. So x minus 1, x plus 1. Okay, since in RHS side it is in the base of 2, but in LHS side there is no base provided you. That's why you consider here according to the RHS base. If it is the base of 2, you also mention the base of 2. And then if both sides are log, that means if log a to the power m equal to log a to the power n, since both sides are log with the same base, then power will be equal. So m equal to n. Therefore this will be x minus 1 and x plus 1. You may write x square minus 1 since it is in the form of a minus b and a plus b. So you may write a square minus b square equal to what? 1. And just simplify it. This will be x square equal to 2 and x is equal to what? Root 2. Now see the question number 12. If log x square minus 21 is equal to 2, so that x equal to plus minus 11. Therefore see, we have log x square minus 21 is equal to what? 2. So you write log x square minus 21 equal to 2. Since there is no base is defined on the log, so you consider base 10. If no base is given, then it is in the base of 10. Is it clear? So you consider log base 10 of x square minus 21 is equal to what? 2. So 10 to the power 2 is equal to what? X square minus 21. convert log into the exponent form. And then simplify 10 square will be equal to what? 100 plus 21. So x square is equal to what? 121. So x is equal to root of 121. You find the root of 121, it will be plus minus 11. Is it clear? Hope you all are able to understand what is the meaning of logarithms and how to apply the logarithms concept. Okay? After these questions, whatever questions are left in this exercise 8a, do by yourself. Hope all of you are able to solve. Is it clear? Okay. And after this topic, we learn about the laws of logarithms. Please make a note. Hello. See, next topic of logarithm is laws of logarithms. That means how to apply the laws of logarithms. That means maybe it will be solved in the form of algebraic expressions, or how we can simplify the complex problem in the form of simplest way. Is it clear? So let's see. Just previous we have already learned this 3 1 2 3. That means log base a to the power 1 is not defined. Log base 10 of to the power 10 is equal to 1. Log base a to the power a is equal to what? 1. Okay. Apart from these 3, we have some more laws about the logarithms. Now see, this is called the product law. This is called the product laws. This is called the product laws. Product law. That means if log base a to the power m into n, if it is in the form of product, the product will be break in the form of algebraic sum. That means log base a to the power m plus log base a to the power n. If there are many terms are in the form of product, this product will be break in the form of algebraic sum. That means here it is m and p. It will be break m plus n plus p. That means log base a to the power m plus log base a to the power n plus log base a to the power p. Okay. Now the next one is a quotient form of the logarithm. That's why this is called the quotient law. This is called the quotient or division. Quotient law. See. That means if the log is in the form of division, that means log base a to the power m by n. If it is in the form of m by n, this will be break in the form of algebraic subtractions. That means log base a to the power log base a of m minus log base a of n. That means log m minus log n. But you must remember here if it is in the form of numerator log base a to the power n divided by denominator log base a to the power n, it will be not break in the same way. Is it clear? You must remember this. It will be not equal to log base a to the power m minus log base a to the power n. Only one log should be there. Here numerator and denominator places are log. That's why it will be not both equal. So now the 3, that means third one is power of log, that is power law. That means log base a or to the power m to the power n. This will be also written as log base a of m to the power n. That means it will be break as n into log base a of n. That means this n will be transformed as a product. That's why it is written as n log base a to the power m is equal to n log m. Simply you can write without base also. There is some examples related to the power of log. So log base a 3 to the power 4. You may write 4 log a to the power 3, or even you can write 4 log 3. Simply log, second example, log 7 to the power x square minus 1. You may write this one x square minus 1 log 7. Even you can write example number 3 as log 2 root of 17. That means you may write log 2 17 to the power 1 by 2. So this will be 1 by 2 log 2 to the power 17. Is it clear? And you must remember one topic, that is one note. Logarithm to the base 10 are known as common log. That means if there is no base is defined, that means you may consider base 10. Is it clear? And you know this thing. Based on this, we have some example. Log 10 to the power 1000. That means you may write log base 10 of 10 to the power 3 is equal to 3 log 10 to the power 10. That means this become what? 1 by this log. So 3 into 1 is equal to what? 3. Similarly for this one also. See it. Now, how to convert the complex expressions into the simplest logarithm form? See, that's why it is written here, expansions of expressions with the help of laws of logarithm. That means some laws are here already done, and how to simplify by using the logarithm. See, we have let y is equal to a to the power 4 into b to the b square divided by c to the power 3. So we have to simplify these algebraic expressions by the logarithm method. So you consider log on both sides. So log y is equal to what? Log a to the power 4 into b square divided by c to the power 3. See, there is no basis declared. That means you may write base 10. Base 10 if you want. So apply the formula. So there is no formula on the LHS side. So directly you write log y only. And here log m by n form. So log m by n form will be break log m minus log n. So here you can break it log m by n. So in place of m is equal to a to the power 4 into b square minus of log c cube. And see, the first part of log of the RHS side, this is in the form of product. So apply again the product log m into n, that means log a to the power n plus log a to the power n. So it will be in the form of log m plus log n. In place of m it is a to the power 4, and in place of n it is b to b square. Is it clear? And see, the RHS side, this is in the form of power of log. That means this way, log m to the power n. You can write n log m. So you may write for 4 log a to the power 4, 4 log a, and log b square 2 log b minus 3 log c. This is the simplest expressions in the form of logarithms. So in this way you can apply the formula and simplify the exercise 8b and 8c. Let me solve some problem related to the exercise 8b and 8c, and rest of the questions attempt by yourself. Okay? Even if there is any problem, just ask me. Okay? Make a note. See, this is exercise 8b, question number 5, 9 and question number 15, okay? And rest of the questions you attempt by yourself, okay? If there is any problem, whenever I got time, I will be solve it and try to upload also. Is it clear? Okay. So now, see the question number 5. Find x if x minus log 48 plus 3 log 2 equal to 1 by 3 log 125 minus log 3. We have to find the variable x. How to find the variable x? That means first we try to remove all the log and convert in the form of what? Without log, or formula of logs only, or laws of log. So we try to make in the unit of the formula in the form of logarithm. That means it is the questions you may write x minus log 48 plus 3 log 2. So 3 log 2 you may write log 2 to the power 3. Okay, and 1 by 3 log 125, you may write log 125 to the power 1 by 3 and minus log 3. Okay, and see, even you can write 2 to the power 3 will be 8, and 125 you can write 5 to the power 3 into 1 by 3. So 3 will be cancelled out, so only log 5 will be remain, and here log 3. And see, transform all the LHS of the logarithm into the RHS here. That means this is minus will be plus and plus will be minus, and log 5 is there and log 3 is there minus. And see here, this first two is in the form of what? Log m plus log n. That means you may write log 48 into log 5, and it is in the form of what? So you again take minus common from this, so this will be plus, so this will be log 8 into 3, and after that this is in the form of log m minus log n, so it will be log m by n. Just calculate this one and you will be get log 10. So you may write log base 10 to the power 10 is equal to what? 1. So the x will be 1. This is of your answer. See the question number 9. Given log x equal to m plus n and log y equal to m minus n. Express the value of log 10x divided by y square in terms of m and n. That means this log expressions we have to find in terms of m and n only. That means we have log x equal to m plus n and log y equal to m minus n. Try to find the value of what? Sorry. First you convert this log in the form of log x and log y. That means now log 10x divided by y square. You may write log 10x minus log y square, since it is in the form of log m by n. And even you can write again it is in the form of log m into n. So log m plus log n. That means log 10 plus log x. And this is in the form of log m to the power n. So it will be n log m. And then log 10. That means there is no base, so you may write base 10. Okay, so log base 10 after is equal to what? 1. And log x is equal to what? M plus n, and 2 times of log y. So log y is equal to what? M minus n. And just simplify this one, and after simplify you will get 1 minus n plus 3n. And after that see the question number 15 from the exercise 8b. If x equal to 100 to the power n, y equal to 1000 to the power b, and z equal to 10 to the power c, find log of 10 root y divided by x square into z to the power 3 in terms of a, b and c. That means same type of questions over here. Just express this one in terms of log x and y and z, and from these three you calculate log x, log y and z. How? See, we have provided now 100 to the power equal to x. That means you may write 10 to the power 2a is equal to x, and even you can write 10 to the power 4b equal to y. And this is directly you can write, you convert this exponent form in the form of logarithm. So log 10 to the power z equal to what? See, and this will be, you may write log 10 to the power x equal to what? Log 10 to the power x equal to what? 2a. Just interchange this power. This also interchanges and find the value of log x and log y. So log 10 base of x is equal to a, log 10 base of y is equal to 4b. And now we have to find the value of log this. So express log m by n in the form of log m minus log n, and again convert this m into n form in the form of log m plus log n. And this is also m into n form, so you may write log m plus log n. Is it clear? So log 10 is there, and you may write this log root of y. So you may write what? 1 by 2 log y to the power 1 by 2, and apply the formula of log m to the power n equal to n log m. So this will transform in the product part. Okay. And minus 2 log x minus 3 log z. How? Again it is in the form of log m to the power n and log m, and minus and plus will minus, and similarly log m to the power n is equal to 3 log z. And just replace log y. The log y is equal to what? Log y is equal to 4b. That means there is no basis here. That means you can write log 10 base, log 10 base, even log 10 base, even log 10 base. So log 10 base 10 is equal to what? 1 by 2 log y is equal to what? 4b. And log 10 base x is equal to what? X is equal to 4b. And log z is equal to what? 3c. And just simplify it, and this is your correct answer. Okay. And after this, you also attempt the exercise 8c. Okay, by yourself. Okay, again I will try to give some solutions from exercise 8c. But before starting 8c, we have one more topic, that is the some more terms related to the logarithms. Okay, and from that concept we will solve the exercise 8d. Okay, please make a note. Now see, the next topic is more about logarithms. That means this more about logarithm is based on the formula of logarithms or laws of logarithms. So how to make a formula in another way? See, we know that 2 to the power 3 is equal to what? 8. So if we change this exponent in the form of logarithms, this will be log 2 to the power 8 equal to 3. Now see, even you can write 2 to the power 3 equal to 8. So you may write 2 equal to 8 to the power 1 by 3. Yes or no? And now convert this exponent in the form of logarithm. So 8 to the power 1 by 3 equal to 2. So log 8 to the power 2 equal to what? 1 by 3. Is it clear? How? Just you change 3 and 8, and here you interchange 1 by 3 and 2 to convert exponent from logarithms. And see what is the difference between these two relations. See here, it is become log 2 to the power 8 and it is become log 8 to the power 2. That means here base is 2 and here base is 8. And here log base 2 to the power 8 and here log 8 base to the power 2. That means interchange both base and exponent. That means if you multiply these two expressions, that means log base 2 to the power 8 into log 8 base 8 to the power 2 is equal to log base 2 to the power 8 is what? 3, and log base 8 to the power 2 is equal to what? 1 by 3. So 3 into 1 by 3 is equal to what? 1. So just to make a formula in this form, log in place of 2 replace a, and in place of 8 replace by b. So log a to the power b into, just interchange a and b, it will be into log b to the power a is equal to what? 1. So even you can write log a to the power b is equal to what? 1 by of log b to the power a. This is the fundamental and basic relation in between log a to the power b to change in the form of reciprocal of log a to the power b in the form of 1 by log b to the power a. And you make a note in another way, log base a of a to the power x is equal to what? X. Since log m to the power n is equal to what? N log m. So a base and exponent are same, so this will be what? 1. So even you can write log a to the power a, so x times or x, and log base a to the power a is equal to what? 1 is equal to x, that's why it is x. Okay, and now this is all about our the logarithms. So up to this topic we have to study about the logarithm. There is no more formula up to class 9, and apart from we have in class 10 also some part of logarithms, and even some formulas will be used, some not, almost formula will be used in class 10 also. That's why you must read very carefully this chapter logarithms. Okay, now see some examples I have taken from the exercise 8d, question number 17 and question number 22. Now see here, question number 17 given x is equal to log base 10 to the power 12, y equal to log base 4 into log base 10 to the power 9, and z equal to log base 10 to the power 0.4. Find x minus y minus z, and number 2 13 to the power x minus y minus z. The first to find x, y and z, just replace x, y, z in this equations or expressions. So in place of x it is given, y is also given, and z is also given. Okay, now make a simplification. So therefore, see, you may write 12 4 into 3 and z, that means 9 you can write 3 to the power 2, and 0.4 you may write 4 by 10. Now see here, you may break this log m into m form. So log 4 plus log 3 with the base 10 and minus log 4 to the power 2. So you may write this one as log 4 base to the power 2 is equal to log base 10 2 divided by log base 10 to the power 4. This is the another formula. So also you make a note for this one, log a to the power b is equal to log base 10 to the power b divided by log base 10 to the power a. Even this is another formula. This formula is not given in your book maybe, but this formula will be used here. Will see. Then next step, so this will be written in this form, okay, and log 10 to the power m to the power n, so 2 log 3, and this is m by n form, so log minus of log n minus of log n, so there is a sign minus, so minus and minus will be plus, okay, and after that see here log 10 to the power 4, and here also minus log 10 to the power 4, so it is in the form of plus and it is in the minus, so both are cancel out each other. So rest of them write it, and even 4 you can write 2 to the power 2, and it is in the form of log m to the power n, so you may write n log m with the base 10. See, log base 10 2 and log base 10 2 are cancelled, even these two and these two will be cancelled, and log 10 base 10 is equal to what? 1, and log 10 to the power 3 as it is written, and rest of the part is equal to what? See, log 10 to the power 3, and here it is log 10 to the power 3 and plus 1. One is plus and one is minus. So both are cancelled out. So plus 1 is only left. So answer is 1. See, the very important questions. These questions why it is very important. See, this formula will be used. Even this formula is used here, but in this form. See, you have to evaluate 1 by log base a to the power bc plus 1, 1 by log b to the power c a plus 1 by log c a b plus 1. Just you convert log a to the power bc in this formula. That means, see, 1 divided by log bc divided by log a. That means what? Log a to the power b is equal to what? Log b is equal to 1 divided by what? Log b to the power, and just interchange exponent and this. So do it. Log bc divided by log a, log ca divided by log b, log ab divided by log c. Okay, and take the LCM in the denominator part. After taking the LCM in each term, so this will be log BC plus log of A divided by log A, log CA plus log B divided by log B, and log AB plus log C divided by log C. And just simplify this. So 1 into log A. Similarly 1 into log B and 1 into log C, and denominator part will be as it is. Okay, and after this same, in each term in the denominator parts are same, log A, log B, log C, log A, log B, log C, log A, log B, log C. So LCM will be same, log A, log B, log C, log A plus log B plus log C. So the numerator part will be also log A plus log B plus log C. Cancel out each other. The rest of the part is equal to what? So this is your answer. Now you solve the exercise 8C and 8D as per possibility. Okay? Please make a note.